Hello everyone. Now let's look at problem 198. This is house robber. Alright, let's go through the problem description. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Given an integer array nums representing the amount of money each house, return the maximum amount of money you can rob tonight without alerting the police. Okay, so from the problem description, I can tell that we are given an int array num, and we want to return the max of sum of I think it should be non-adjacent houses. Okay, I think I kind of get it. Maximum sum of non-adjacent houses. Now let's look at the example to understand the problem further. So example 1, we have 1, 2, 3, 1. Alright, so 1, 2, 3, 1. So let's try out how this is gonna work. So if we take the first one, then we take the second one, that would give us 4. If we take the first one and the last one, then it will give us 2. Now if we take the second one and the fourth one, now that would give us 3. So the maximum here is 4. Rob 1, house 1, money 1, and then rob house 3, money 3. Total amount you can rob is 1 plus 3, which is 4. Correct. Second example, we have 2, 7, 9, 3, 1. So if we rob house 1, house 3, and house 1, that would give us 12. However, we could also rob house 1 and house 4, but this would give us just 5. We can and then there are no other ways if we want to rob house 1. How about we rob house 2? So we skip the first house, and then we can rob the house 4. This will give us 10. If we rob house 2 and 3, we cannot rob. 4, we can rob it, and then 5. So let's try 2 and 5, give us 8. If we rob house 9, we might as well rob house 2. So that would there is no point to skip house 1 and go to rob house 9. So here we see that the answer is 12. Let's check if it is correct. And yes, the answer is correct. It is 12. Route house 1, money 2, route house 3, money 10, money 9, route house 5, money 1. So that would maximize the amount of money we get. I think I got the problem now. I understand the problem now. I'd just like to clarify a few things. So let's write down the clarify step. Question 1. What are the range of nums? Can I make sure that there is at least one houses? Here we are given that it is between 1 to 100. Second example, I know the amount of money is valid, i.e. it is larger than 0. So here we are given that it is between 0 to 400. Reasonable. I think there are no any more constraints that I need to clarify. Now I would like to explore possible approaches for this problem. So I think when I go through the example 1 and example 2, I think it's obvious that if I want to rob house 3, I might as well rob house 1. So let me write down the finding. If rob rob 3 we might as well rob 1 because it doesn't harm as there is no negative value here. So I think from here we can see that if we want to rob for the nums, then okay, let me write down something here. If I want to rob nums, so let me write down f of nums. This should be equal to max. Oh, either I rob the first house. So if I rob the first house, then that would be nums of 0 plus f of nums of. Now we cannot rob the first house. I mean, we have robbed the first house, it means we cannot rob the second house. Now that would leave us the remaining after removing 2 houses towards the end. Or we could also rob the second house in the row, and then it would leave us with the from the 4th houses onward. So I think this describes the problem pretty much. Alright, let me try to use this recurrence function and then apply to our example there. Okay, so first example. I think let's try to do it in a bottom-up fashion. So let's make it 1, 2, 3, 1, and then the nums is here, and then the f is below it. Okay. So if there is only house 1, then they would give us just one. If there is a second house, then there is we can take that. We can take the first one, and then F3, it would be 3 plus plus 1 is 4. Actually, let me write down in vertically so that it makes more sense here. So F, uh, okay, let's do it this way. So if n is 1, then we could row house 1 only, which is 1. Okay, I think let's write down the base case as well. F of empty list is 0. Okay, because there is no house to row. And then when n is 2, let's see what we can do here. We could rob itself, and we could rob the house, or we could also skip and then rob the first house there. Now that will give us 2. If n is 3, that will be the max of 3 plus 1. Or we could also rob house 2. That will give us 4. When n is 4, then we take the max of 4. Oh, sorry, it's 1. 1 plus 2. Or we could skip the current one and then take the previous, which is 4. And 4. So 4 is our answer, which is correct. Now let's try the second example. We have 2, 7, 9, 3, 1. Okay, when n is 1, we have 2 there. When n is 2, then we can choose between 7 and 2, which is 7. And then when n is 3, we could take 9 plus 2, or we could take the previous one, so that would give us 11. When n is 4, we could take 3 plus 7, or we could also take the previous, which is 11. In this case, we take the previous one. When n is 5, we could take 1 plus 11, or we take the previous one. This would give us 12, which is correct. So I think this is pretty much it. Yeah, so I think that's about it for this problem. Does this sound reasonable to you? I'm pretty good about this. And may I proceed to program? Unless there is a further optimization that you would like me to explore. Alright, now let's proceed to the implementation. So how are we going to do this? I think we can do this iteratively, as I have shown you in the walkthrough of the example. So basically, we start with the smallest one, and then we move up. Then we can use the same concept that we did before. We can use F1 and F2. So how about we do that? So let me initialize F1, F2 to 0. And then we are gonna look through the house. So for n in num, F1, F2 equals F1 will be F2, and then F2 will be the max of F1 plus n, or it could be F2. At the end, we just return F2. I think this should work. Let me go through the code again to make sure I don't miss anything. I have F1 and F2, and then there is a loop to look through all the houses. And then in that, we are gonna store it into F1 and F2. F1 will be storing F2 in the next iteration. Then F2 will be the maximum of F1 plus the current one, or we could take F2, which is the previous houses without anything else. Now let me test the code with our example to make sure everything works as expected. Example 1, we have F1, F2 set to 0, and then F1 would be 0, F2 would be 1, and in the next iteration, F1 is gonna be 1, F2 is gonna be 2 or 1, which we take 2, and then N3 we take 1 plus 3, or it could be 2, and this case we take 4, n equals to 4, then we could either take 1 plus 2, or we could also take the previous one, which is 4. Alright, we got it correct for example 1. Example 2, we have when n is 1, we have 0, 2, n is 2, we have 7 or 2, we take 7, and 3 we take 9 plus 2, which is 11, n equals 4, we don't take it, so we take the previous one, which is 11, n equals 5, we take 1 plus 11, which is 12. Alright, so I think it looks good to me. Now let me input our solution into LeetCode. I think it should work. Now F1, F2, actually let's call it F1 and F2 equals 0. Now for n in num, call it num pref1 pref2 equals pref2 comma max of num plus pref1 or it could also be pref2. Now we return the pref2. Let's try to run this. And we got it correct. Let's submit it. Hopefully we got it correct. And yeah, we got it correct. So runtime is good. Let me put it down. Time is on, and then the space is 01 because we use pref1 and pref2 variable. Let's quickly go through some example by others. So I think everyone is pretty much doing the same thing. Alright then, I think we're gonna stop here. So thank you everyone.